Alright, so the piston of a reciprocating engine is basically a cylindrical member which moves back and forth within a steel cylinder. The piston acts as a moving wall within the combustion chamber. As the piston moves down in the cylinder, it draws in the fuel and air mixture. Then as it moves upward, it compresses the charge, ignition happens, and the expanding gases force the piston downward. This force is transmitted to the crankshaft through the connecting rod. On the return upward stroke, the piston forces the exhaust gases from the cylinder, and well, the cycle just repeats. So, the majority of aircraft engine pistons are actually machined from aluminum alloy forgings. Grooves are machined in the outside surface of the piston to receive the piston rings, and cooling fins are provided on the inside of the piston for greater heat transfer to the engine oil. Pistons may be either the trunk type or the slipper type. Slipper type pistons aren't really used in modern high-powered engines because they just don't provide enough strength or wear resistance. The top of the piston, or head, may be flat, convex or concave. Also, recesses may be machined in the piston head to prevent interference with the valves. Modern engines actually use cam ground pistons that are a larger diameter perpendicular to the piston pin. This larger diameter keeps the piston straight in the cylinder as the engine warms up from initial startup. As the piston heats up during warm-up, the part of the piston in line with the pin has more mass and expands more, making the piston completely round. At low temperatures, the piston is oval-shaped and, when it warms to operating temperature, it becomes round. This whole process reduces the tendency of the piston to cock or slap in the cylinder during warm-up. When the engine reaches its normal operating temperature, the piston assumes the correct dimensions in the cylinder. So, as many as 6 grooves may be machined around the piston to accommodate the compression rings and oil rings. The compression rings are installed in the 3 uppermost grooves, while the oil control rings are installed immediately above the piston pin. The piston is usually drilled at the oil control ring grooves to allow surplus oil, scraped from the cylinder walls by the oil control rings, to pass back into the crankcase. An oil scraper ring is installed at the base of the piston wall or skirt to prevent excessive oil consumption. The portions of the piston walls that lie between ring grooves are called the ringlands. In addition to acting as a guide for the piston head, the piston skirt incorporates the piston pin bosses. The piston pin bosses are of heavy construction to enable the heavy load on the piston head to be transferred to the piston pin. The piston pin joins the piston to the connecting rod. It is machined in the form of a tube from a nickel-steel alloy forging, case-hardened, and ground. The piston pin is sometimes called a wrist pin because of the similarity between the relative motions of the piston and the articulated rod, and that of the human arm. The piston pin used in modern aircraft engines is the full floating type, so called because the pin is free to rotate in both the piston and in the connecting rod piston pin bearing. The piston pin must be held in place to prevent the pin ends from scoring the cylinder walls. A plug of relatively soft aluminum in the pin end provides a good bearing surface against the cylinder wall.